Hello students, myself Manuj from Scholars Forum. Again I welcome you all to this homemade video series of class 11th and class 12th topics. Now today we will extend our stoichiometric topic. In the previous video we discussed about the mixture analysis. In this video we will be discussing something about percentage purity. If you wish to go through the previous video, you can find the link right up here. Also, you should find a DPP where some questions are given in the comment section or in the description of this video. Okay, so let's start. See, first topic is percent purity. Percent purity. Now, जैसा कि आप सभी जानते हैं कि आजकल मिलावट का जमाना है, तो कोई भी चीज अगर आप जो मार्केट से खरीद के लाते हो वो 100% प्योर हो, इसकी कोई गारंटी नहीं है ना। जैसे सपोज आप 1 लीटर दूध लेकर गए, पता चला दूध वाले ने उसमें 90 एंड 900 ml आपको दूध प्योर दिया और 100 ml अपनी ओर से पानी मिला दिया। Regarding this thing, so we will say कि since a milkman added 100 ml water in 1000 ml of milk, so pure milk was 900 ml. तो इसका मतलब परसेंट प्योरिटी क्या हुई हमारे मिल्क के सैंपल की 90%। ओके, आप 1 किलो चीनी लेकर के आए, उसमें से आधा किलो निकल गया कंकड़ पत्थर, तो प्योर चीनी कितनी मिली? प्योर मिली आपको हाफ केजी, तो कितनी परसेंटेज प्योरिटी हुई? 50%. Similarly, how are we calculating this percentage purity? Percentage purity of a given sample is calculated by this formula, where pure quantity present upon total quantity of sample multiplied by 100. Okay, pure quantity present means let's say आप गए थे मार्केट, you brought 1 kg sugar और पता चला इसमें आपके हाफ केजी आपके निकल आए stones, तो percentage purity will be 1000 minus 500. What is 1000? 1000 means 1000 gram of sugar minus 500 gram of stones, means this is your pure sugar, divided by 1000 actual quantity of your sample multiplied by 100, so it will come as 50%. Now I hope you understood what is the meaning of percent purity of a given sample. Now let's move forward to the first problem. By that you will understand easily. And one more thing, as you know, this video is being recorded at my home, so please pardon the background noise as well. Okay, now let's start our first problem. First problem is a 100 gram of a sample of MgCO3 produce 33 gram of CO2 upon heating. So what they are saying is find percentage purity of MgCO3 sample. Okay, now in such type of question, what are approaches? If what we do, whatever data we are certain about, so we will start our calculation from that data. मतलब जैसे आप किसी एक डेटा के बारे में बिल्कुल एक अच्छे से कंफर्म है कि नहीं ये तो प्योर है, तो उसके बेसिस पे हम फर्दर कैलकुलेशंस करेंगे। ठीक, लाइक यहाँ पे क्या है, लेट्स सी कि वी आर गिवन 100 ग्राम ऑफ सैंपल. फर्स्ट ऑफ ऑल टेल मी, is 100 gram of sample of MgCO3 is pure? Yeah, is it 100% pure? No, it is not 100% pure. Maybe it is 100% pure, but I don't know. Why? Because see, in the question only they are saying कि find percentage purity of MgCO3. Means I cannot say कि इस 100 gram में पूरा का पूरा 100 gram MgCO3 होगा. So we will not go for this data. This data is absurd to us, means this data is a total weight of our sample, but we don't know कि how much amount of pure MgCO3 is present. Okay, one more data they have given. They have given it produced 33 gram of CO2. Now how MgCO3 produces CO2? I hope you remember when we heat MgCO3 we get MgO plus CO2. Now CO2 will be evolved and MgO will be deposited. Now you tell me, CO2, this amount of CO2, it is released. Earlier it was not present. But when you heated the sample, CO2 was produced and this much amount of CO2 you collected. Is this clear? Now tell me, which data is more correct? 33 gram of CO2 means this data is more correct, or this 100 gram of MgCO3 is more correct? Definitely 33 gram of CO2 is more correct. Why? Because this is the amount of CO2 which is formed right now in front of your eyes. आपकी आंखों के सामने पैदा हुई है 33 ग्राम, तो ये तो आपको पता ही है कि ये प्योर है. तो I will say how many moles of CO2 actually have been produced? Total moles of CO2 produced will be 33 divided by 44. 33 weight of CO2 produced divided by molecular mass of CO2 means this much moles. Means how many moles? See, I think it is cancelled by 11, so 3 by 4 moles. Okay, now let's see. Each CO2 is produced by how many moles of MgCO3? 1. 1 CO2 is produced by 1 MgCO3. Okay, so 3 by 4 moles of CO2 will be produced by how many actual moles of MgCO3? 3 by 4 moles. Do you know what is written in this arrow? Here it is written, statement will be read from here, like 3 by 4 moles of CO2 is formed by 3 by 4 moles of MgCO3. If you want to write in unitary method, you can write in this manner. 1 mole of CO2 is produced by 1 mole of MgCO3. So 3 by 4 moles of CO2 will be produced by 3 by 4 moles of MgCO3. Okay, good. Now, can you tell me the weight of MgCO3 actually present? Weight of MgCO3 pure actually present. How much it will be? Think about this. Now this 3 by 4 mole, is it pure or impure? It is 100% pure. This 3 by 4 moles that you have calculated, it is 100% pure because these moles only are producing this CO2. Now, are you getting this thing? Good. So बताओ यहाँ पे weight of MgCO3 pure will actually present will be how much? It will be 3 by 4 means moles of MgCO3 multiplied by its molecular mass. Now molecular mass कितना होगा MgCO3 का? What will be the molecular mass? It will be 84. So see, it is coming as 63 grams. It is coming as 63 gram. Means this 63 gram is the pure weight of MgCO3 present. Where? In 100 gram of sample. Now, since they ask about percent purity, so percent purity, how will we calculate? We will calculate actual weight upon weight of sample. Actual weight of what? Actual weight of exact pure sample multiplied by 100. So it is coming as 63 by 100 multiplied by 100 will come as 63%. So out of this 100 gram, you have just 63 gram of pure MgCO3. Rest 37 gram is dirt, sand, it could be anything, but MgCO3. Okay, let's move forward. Now, the next question is, if for reacting with 0.1 molar 2 liter HCl, 10 gram of NaOH was required. Okay, so you have to find the percentage purity of NaOH solution. Question is clear? Pause the screen and try it once. Okay, now let's see. If what reaction is going on? Reaction is happening this HCl plus NaOH gives us what? H2O plus NaCl. We know this reaction very well. Now, out of these two data, about which data you are more certain कि भाई ये तो correct दिया ही है, किस data के बारे में आप ज़्यादा certain हो? भाई देखो 0.1 मोलर दिया है HCl का और 2 लीटर लिया है. So this data is accurate or inaccurate? This is accurate ना. It is 0.1 molar solution. You know कि 1 liter contains 0.1 mole and 2 liter solution is given. Okay. And one more thing. They have given this 10 gram of NaOH. Now I don't know about this 10 gram of NaOH. How I don't know? Because they are asking find percentage purity of NaOH solution. Means they are asking, they have no idea about the sample. Is it pure or impure? That's why they are asking, tell me whether NaOH sample is pure or not. Are you getting this? So let's see how can we solve this question. So just like previous, what we will do, we will try to find the pure means exact data from this which is correct to our knowledge, और उसके basis पे we will try to find the incorrect data or the unknown data. So here I am saying how many moles of HCl we have. Moles of HCl will be how much? Moles of HCl will be 0.1 multiplied by 2, that is 0.2. How? Molarity multiplied by volume in liter. This gives us moles. Now 0.2 moles of HCl I have. Now can you tell me how many moles of NaOH will be required? NaOH moles required will be 0.2 moles. Why? Because 1 HCl reacts with 1 NaOH, so 0.2 will react with 0.2 NaOH. Okay. Now let's find the weight of NaOH. Weight of NaOH actually required. Weight of NaOH actually required equals to how much? It is 0.2 multiplied by 40. Moles of NaOH multiplied by molecular mass of NaOH. Now please pardon the background noise. Okay, so how much we are getting here? Let's see. We are getting here 8 gram. We are getting 8 gram. So means for reacting with 0.2 moles of HCl, I needed just 0.2 moles. Oh sorry, I needed just 8 gram of NaOH. 0.2 मोल से रिएक्ट करने के लिए बस 8 ग्राम NaOH चाहिए था और मैंने कितना NaOH यूज कर लिया? देखो मैंने यूज कर लिया 10 ग्राम ऑफ NaOH. सो दैट मींस 2 ग्राम NaOH में मींस आउट ऑफ 10 ग्राम जस्ट 8 ग्राम्स आर रिक्वायर्ड एंड रेस्ट 2 grams आर वेस्ट फॉर यू. दे कुड बी सैंड, दे कुड बी डर्ट, डजंट मैटर. ओके, नाउ परसेंट purity of NaOH will be how much? It will be pure weight. See, this actually require pure weight divided by weight of sample, 10 gram NaOH multiplied by 100. How much it is coming? 80%. I hope this phenomenon is clear to us. Okay, good. Now let's move to the next type of problem. It is sequential reaction. Sequential reaction, I hope name suggests कि sequence wise reaction means when one reaction will be completed, then second reaction will be started. When second reaction will be completed, then third reaction will be started. When third reaction will be completed, then fourth reaction will be started and so on. Okay, एक काम खत्म हो तो दूसरा चालू करो. It's like that. भाई बिल्कुल हमारे इसी तरह है कि अगर मान लीजिए आप क्या कहते हैं, यहाँ से आप मान लीजिए आप डिसाइड करते हो अपने घर से कि हमें रेलवे स्टेशन जाना है, तो आप कैसे जाते हो कि लाइक आप पहले जाते हो तो अपने घर के बाहर निकलते हो, घर के बाहर निकलने के बाद लाइक यू कैच द ऑटो, ट्रक, बस और वट एवर यू हैव, तो आप ऑटो या बस से जाते हो, स्टेशन उतरते हो, स्टेशन उतरने के बाद में आप फिर जाते हो अंदर वॉक करते हुए रेलवे प्लेटफॉर्म की ओर. तो दीज ऑल आर सीक्वेंशियल ना, कि पहले आप घर से बाहर निकलोगे. ओके, इट्स नॉट लाइक कि हम सीधे घर में भी खड़े हुए अचानक से हम ऑटो के ऊपर बैठ गए, ऐसा नहीं होगा. कि फर्स्टली आप घर के बाहर निकलोगे, ये सीक्वेंस में है, फिर आप ऑटो हायर करोगे, फिर उसके बाद में ऑटो कैब के बाद में आप जाओगे रेलवे स्टेशन को उतरने के बाद आप वॉक करके जाओगे फिर रेलवे स्टेशन के अंदर. तो दीज ऑल इवेंट्स अकर इन सीक्वेंस. इट्स नॉट लाइक कि आप ऑटो में बैठते ही रेलवे ट्रेन में बैठ जाओगे, नहीं, ऑटो में बैठ के आपको पहले ट्रैवल करके वहां स्टेशन पे भी उतरना पड़ेगा. So it's like every event is connected to the previous one. Until unless previous event is not completed, so you cannot start your new event. So यहाँ पे क्या है, देखिए let's take an example and this example will make things clear. Here what is happening? A is forming 2B. Okay, A से हमारा 2B बन रहा है. Then B is forming 3C. Then C is forming D plus 2E. Question is कि find the moles of E formed if initial moles of A were 3. Means initially we had 3 moles of A. Now they are asking how many moles of E will be formed. Question is clear? Now let's assume that these reactions are first of all balanced. These all reactions must be balanced. Without balancing we don't perform react question in mole concept. Now see, I hope you can understand here that whatever B will be formed in this step, that B has become the reactant of second step. See, B gives you C. So C is the product of second step. Now C has become reactant of third step. Like that. So now see, I hope you can see here. Let's solve this question. It will take hardly 1 minute or maybe less than 1 minute if you follow my instruction. See here. Here what is written? 1A forms 2B. 1A forms 2B. Now how many moles of A you have? You have 3 moles. So 1 mole of A forms 2B. So 3 will form how many moles of B? It will be 6 moles. Are you getting this thing? Unitary method. Okay. Now you have got how many moles of B here? 6 moles. कहां से लिख रहा हूं मैं? From where I am writing? I am writing from this step. कि यहाँ अगर 6 moles बने, so that means here 6 moles will be present. Now each mole of B forms how many moles of C? As you can see, each mole of B forms how many moles of C? 3 moles. So 6 moles of B will form how many moles of C? It will form 6 3s are 18 moles. Isn't it? 1 forms 3, so 6 will form 18 3 times. Now, how many moles of C you have got from second step? You have got 18 moles. Okay, now see here. Each mole of C gives you 1 mole of D and 2 moles of E. 1 mole of C gives you 1 mole of D and 2 moles of E. Now you have 18 moles of C. So can you tell me how many moles of D will be formed? Moles of D will be formed how much? 18 moles. And how many moles of E will be formed? It will be 18 into 2, that is 36 moles. That's it, solved. Now look at these arrows. What is written in this arrow? It is written forms. Here also it is written forms. Here also it is written forms. I told you I will stop writing in detail. Now remember, I hope this sequential reaction question is clear to us. Okay, let's move to the next problem. Now let's see next problem. Next problem is find the moles of CO2 formed if reaction was started from 0.5 moles of C2H2. Means you started the reaction by 0.5 moles of C2H2. Now you have to find the moles of CO2 formed. These reactions are given to you. Now what you have to do, and one more thing is given, assume other reactants are present in excess. Let me tell you, if this statement is given or not given, you have to take other reactants in excess. Okay, doesn't matter whether this statement is given to you or not. Now let's start. So what should be our first step? Our first step should be, we should balance all the reactions. Okay, please try to balance these reactions and pause the screen and give it a fair try to this question. Let's see, can you do it or not? Now, how will we balance this? Let's see. Here 2H2 and 2 hydrogen, 6 hydrogen, 2 carbon, 2 carbon. That means if I make it 2H2, so first reaction will be balanced. Now let's see this. C2H6, C2H2. This is balanced. This looks like balanced. Now here C2H4 plus O2 gives us CO2. Carbon is not balanced, so 2 CO2. This is combustion equation actually. Here 4 hydrogens and here just 2 hydrogens. So let's make it 2H2O. Now how many hydrogen here? Oxygen here, 2 to the 4, 10, 3, 6. So let me write here 3O2. So this is your balanced equation. Now see how quickly we can solve this question. You are given 0.5 moles of C2H2. Okay. Now, one C2H2 form how many C2H6? 1. So 0.5 will form how many C2H6? 0.5. Okay. Now, similarly, 0.5 moles you got C2H6 from this step. So let me write here 0.6 or 0.5. Okay. Now, one C2H6 forms how many C2H4? 1. So 0.5 will form how many C2H4? 0.5 moles. Okay, 1 forms 1, so 0.5 will form 0.5. Now, see this 0.45 will come here. Now, 1 C2H4 forms how many CO2? 2. So, 0.5 will form how many CO2? 0.5 into 2, that is 1 mole of CO2. That's our answer. Okay, question is clear to us? Good. Let's move forward. Now, next topic is very interesting. It is percent yield or efficiency of reaction. Percent yield or efficiency of reaction. Let me tell you the formula first. Percent yield equals to actual product formed, whatever its mass is or moles is or volume is, divided by expected product formed, mass or moles or volume, whatever, multiplied by 100. Means it's like you can say, in Hindi we call it jitna mila. Means what you got divided by जितना सोचा था. Means whatever you thought. Multiply by 100, isn't it? We all dream of so many big things. हम देखते हैं हमारे पास 1 करोड़ रुपए हो जाए, 2 करोड़ रुपए हो जाए, कि हमने सोचा भाई आज तो जाएंगे बाहर और हम 10,000 रुपए इकट्ठा कमा के लाएंगे एक दिन में, या 1 लाख रुपए कमा के लाएंगे. सोचा 1 लाख कमा के आएंगे, आए 10 रुपए. सो कितना हमने परसेंट एफिशिएंसी लिए, हमने वर्क किया भाई. सोचा था कि आएंगे 10 to the power 5 मीन्स 1 लाख, आए कितने 10. हमारी एफिशिएंसी कितनी रही 10 upon 10 to the power 5 multiplied by 100. That is 10 to the power minus 2%. Very poor efficiency. Okay, it's just like कि जैसे मान लीजिए कि आपने 1 लीटर दूध लिया, you took 1 liter milk, you put it in a bucket, और तुमने अपने एम्प्लॉय को दे दिया. You gave it to your employer, you just said कि okay, give it to that person, deliver it to the home. तो वो डब्बे में दूध लेकर के 1 लीटर दूध लेकर के जा रहा है, बट रास्ते में ये स्किप लाइक ये हिलते हिलते आराम से जा रहा है, तो उससे बहुत सारा दूध गिरता जा रहा है. तो बहुत सारा दूध गिरता जा रहा है. लाइक वो जब घर पहुंचा तो यू फाउंड कि ओनली 200 ml मिल्क वाज लेफ्ट. रेस्ट व्हाट हैपेंड टू 800 मिल्क इज फॉलन. 800 मिल्क वो पूरे रास्ते फैलाते हुए चला गया. सो व्हाट इज द एफिशिएंसी ऑफ योर वर्कर? व्हाट इज द एफिशिएंसी ऑफ योर वर्कर? यू थॉट कितना सोचा था आपने? You thought कि I will be delivered 1000 ml of milk. Now actually how much you got delivered? 200 ml. So your percent efficiency will be 200 divided by 1000 multiplied by 100, that is nothing but 20% only. Are you getting this thing? So जितना मिला upon जितना सोचा था multiply by 100, that is your percent efficiency. Formula is clear to us? Now let's see an example and understand how do we apply this concept in our reaction. See, the problem is find the moles of iron formed if 80 gram of Fe2O3 is reduced by following reaction. What is the reaction? Fe2O3 plus carbon gives us Fe plus CO. And see, one data is written over this arrow, it is 80%. What is the meaning of this? This reaction has efficiency how much? 80%. Meaning this is clear. What is the meaning of writing this 80% on this arrow? Okay, means whatever you will think कि इतना product मुझे मिलेगा, so you will not get exactly what you thought. You will get its 80% only. Means if you thought I'll get 1 kg of iron, so you will not get 1 kg of iron, you will get just 0.8 kg of iron, that is 80% of 1 kg. Okay, like that. Now let's see, our first step should be what? We should balance this reaction. How will we balance it? Let's see. So if I balance it, see here 2 iron, here just 1 iron, so 2, here 3 oxygen, so here 1, so 3, it should be 3. So this reaction is balanced. Now, can you tell me how many moles of Fe2O3 I have? Moles of Fe2O3. How many I have? Let's see. What is the weight of Fe2O3 I have taken? 80 gram. Now, what is molecular mass of Fe2O3? Let's see. Iron has atomic mass how much? 56. So 56 into 2 plus 3 into 16 means how much? 112 plus 48. That means 160. So 160 is the molecular mass of Fe2O3. So means how many moles you have taken? Half. I hope this thing is clear to us. Good. Now, so I have written half moles here. This is what? Moles of Fe2O3. Now, let's solve this question very quickly. See, 1 mole of Fe2O3 forms how many moles of iron? 1 mole of Fe2O3 forms 2 moles of iron. So, half moles will form how many moles of iron? 1 forms 2. So, half will form half into 2, that is 1 mole of iron. Now, you think about it. Is this the mole which you got, or is this the mole which you thought you will get? मतलब ये जितना सोचा है, जितना मिला है, एक्चुअली ये वो मोल है या इतना आप सोच रहे हो कि इतना मिलेगा? Are you getting this? So this is the mole that we are thinking. Okay, we should get 1 mole of iron because how many moles of iron oxide we have taken? Half mole. So we thought कि 1 mole of iron will be formed. But जो आप सोचो वो हो जाए ऐसा जरूरी नहीं. तो 1 mole of iron we thought we will get, but this is what? Expected mole. You can say this is your expected mole. Or you know what will be the actual moles? Actual moles of iron will be how much? 80% of expected. Why? Because 80% is the efficiency of this reaction. So it will be 80 by 100 multiplied by 1, that is 0.8 moles. That's it. Are you getting this? Okay, good. Let's move forward. Now, let's solve a very difficult problem. See, A gives 2B, 4B gives 5C, and 2C gives 3D. This is what? Sequential reaction. And see, each reaction has given efficiency. First reaction has efficiency how much? 50%. Second step is efficiency how much? 60%. Third step has efficiency how much? 80%. Now what they are asking? They are asking find the moles of D formed if 1 mole of A was taken initially. Okay. Now let's see how quickly we can solve this. Okay. If you want to give this question a try, pause the scheme and try on your own. Let's see. We have 1 mole. We have 1 mole of A in the beginning. Now, each mole gives us how many moles of B? 2 moles. So 1 mole will give us 2 moles of B. But what is this amount? 2B. What is 2B mole? 2 moles of B is what? It is your actual amount that we are going to get, or you are thinking we will get 2 moles of B. You are thinking this is your expected amount of B. But what is the efficiency of this reaction? Efficiency of this reaction is 50%, means whatever you will think here, you will get its 50% only. Are you getting this? You thought you will get how many moles of B? 2, but you will not get 2 moles of B. You will get just 50% of 2, means, let me write here, moles of B formed. Let me write like this. The moles of B formed equals to 2 into 50 by 100, coming as 1 mole. Is actually how many moles you got here? You got just 1 mole of B. I think it is clear to us. Good. Now, whatever moles you got here will be written here. See, you got how many moles of B? 1 mole. Now think about this. The 4 mole of B forms 5 mole of C. 4 mole of B forms 5 mole of C. So 1 mole will form how many moles of C? 4 forms 5. So 1 will form 5 by 4 mole of C. But this is what? This is expected, or this is amount you are going to get? This is your expected. Now you are just making the calculation. See, 4 gives 5, 1 gives 5 by 4. This is ideally you are going. But this much amount you are not going to get. How much amount you are going to get? You are going to get just 60% of 5 by 4. Means moles of C, let me write this time actual formed equals to, is it 5 by 4? No, 60% of 5 by 4, means multiply by 60 by 100. So let's solve this as well. So how much we are going to get? We are going to get 30 upon 40. 30 upon 40 means 3 by 4 moles. Okay, is it clear? Good. Now you got here how many moles? You got just 3 by 4 moles actual. So I will write here actual moles only. So I got here 3 by 4 moles of C from the previous reaction. Remember, just here these 2, 4, 5, 3, these are stoichiometric coefficients. These are not the moles. These are just the relation. I hope you remember the first class of stoichiometry. Now 3 by 4 moles of C. See what is written here. The 2 mole of C forms how many moles of D? 2C forms 3D. 2C form 3D. So let me write it here. The 2C forms 3D. So tell me, 1C will form how many D? 3 by 2D. Okay, unitary method. 2 रुपए में आती है 3, तो 1 रुपए में आएंगी 3 by 2. Now we got how many moles of C? We got just 3 by 4 moles. So 3 by 4 C will form 3 by 2 into 3 by 4 moles of D. Are you getting this thing? So how many moles of D we are going to get? We are going to get 9 by 8 moles of 9 by 8 moles of D we are going to get. But is this the amount which you are thinking or you are actually getting? What is this? 9 by 8. We just made a simple calculation. That means we thought. That means if we thought we will get 9 by 8 moles of D. But what is the efficiency of this reaction? 80%. So you will not get 9 by 8 moles of D. You will get its 80%. So moles of D actual formed equals to how much? It will be 9 by 5, 9 by 8. No, it will be 80% of 9 by 8. So see, this got cancelled. This also got cancelled. How much you are getting? You are getting 9 by 10 means you are getting 0.9 moles. I hope this thing is clear to us. Okay, and please pardon the background noise. Okay, let me give you one more question. Now this is the question given to you. Question is, A gives 2B, efficiency of this reaction is 20%. 2B gives 3C, efficiency of this reaction is 60%. C gives 2D, efficiency of this reaction is 50%. And it is said you got 1 moles of D. You got 1 mole of D. So this is your actual moles of D you got in the reaction. Question is, find the moles of A taken initially. Now you have to find how many moles of A you took in the very beginning. Okay, For your hint, let me say let's assume you took X moles of A initially. Okay, you took X moles of A initially. Now solve the question on your own. Leave your answer in the comment section. Okay. So in this video, up to here only. In this video, we discussed about percentage efficiency of this reaction, very important. Percent purity we also discussed. We discussed about sequential reaction, 3 special type of reactions we actually discussed. And in the next video, I will be discussing about very useful tool for solving questions in NEET or IIT JEE Main. We will discuss about PAOC, Principle of Atomic Conservation. Okay, so stay tuned and have a good day.